Eric Burgess here, and we've been given the following question. We're letting x equal 0.9 repeating, so just 0.99999 on forever. And we're given a bunch of questions about this strange repeating decimal. The first one's sort of a gut check. It just wants to see what you think. Part A, is x less than 1 or is x equal to 1? So you're right. You know 0.9 is definitely less than 1, but 0.99 is pretty closer to 1. And with 0.99, that's even closer. And if you go 0.9 forever, is that the same thing as 1? So it just kind of, this one's sort of here to just say, what do you think? What's your hypothesis here? So I'm not going to answer this one yet. It kind of spoils it. So just whatever you think here for part A, just write it down. You don't need to be right on this one. Just kind of up in the air. What's your gut check? Okay, so let's go over to part B. So we're going to do B, which will tell us a little bit more about what's going on here. So we want to write a geometric series to find the value. So we can rewrite repeating decimals in the form of a geometric series. And so let's go ahead and do that. And this will tell us, is it 1? Is that possible? So 0.9 repeating is the same thing as, right, we have s of n is equal to 0 plus, and then for the first 9, that's 9 over 10. For the next 9, that's 9 over 10 squared. For the next 9, that's 9 over 10 cubed. And this goes on and on and on until we get 9 over 10 to the n. Now, looking at this, we say, well, our first term is a, and that is 9 over 10. So a is equal to 9 over 10. And our thing that's going up every single time is this power of 10. So we're multiplying by the common ratio of 1 over 10. So knowing that the geometric series sum is 1, or not 1, it's a over 1 minus r, then we can say that the sum of this series, s, is 9 over 10 over 1 minus 1 over 10. And if you plug this into your calculator, you'll get 9 over 10. We'll just do it shorthand. So 1 minus 1/10 is 9/10. That's 9/10 over 9/10. That is equal to 1. And so we see here that it is, in fact, this exact same thing as the number 1. So pretty wild right here that we can have 1.9 forever, and that's the same thing as 1. If you just go out forever, that's the only requirement. Just do it forever, and you'll get 1. So pretty interesting there. So part C wants to know how many decimal representations does 1 have. So we definitely have one of those right here, right? We know that 0.9 repeating is 1. But there's another way to write it. It's considered trivial, but it is another way to write the decimal, and that is 1.0. With the 0 repeating forever, right? We don't write this bit because it's considered, a waste of space to have so many just trailing zeros forever, but it's there technically. And so we really have two ways to write this thing, and pretty interesting. It's just a weird thing. So let's go ahead and go over to D. So the answer would be on that one. There's 2. And then it says, which numbers have more than one decimal representation? Well, this kind of gives us some insight on that, because look at this. Anything that's got zeros trailing afterwards is going to be a problem, because we could always replace it with 0.9 repeating and subtracting 1 from the last spot. Let me show you what I mean. So if we have the number 1.2, well, there's actually zeros after this, right? On and on and on. So we could write this as 1.1, subtract it from the last spot, 9999 repeating. We could have, for example, the number 5. This one should be obvious. We could write that as 4.9 repeating. We could have the number, let's see here. We could have the number 1.212. That's the same thing as 1.2119 repeating, because this is going to become a 1, and that's going to make this go back up to a 2. So anything that terminates, anything that ends is going to have the ability to do this. So you could write this the way I wrote it. It's not as fancy. There's probably fancier ways to say this, but any number that ends. So numbers like pi, no dice, doesn't end, or e, no dice, doesn't end. But if the number ends, if it's a decimal and it has a last spot, you could always just replace that last spot, subtract 1 from the very last place, like the 2 here, and then just put 9s forever after it and technically be the same number. So this is the way I chose to say it. You could, have like 3. So there's that. So kind of a cool question, sort of sets you up to think a little bit more carefully about decimals and how they work and some of the strange behaviors that they can show, especially when they're repeating. But very, very cool. If you have any questions about this, feel free to let me know and we'll catch you in the next problem.